I distribute the 5. So 2x minus 3, everything cubed, and x squared plus x plus 1 to the 4th. 5 times 4x squared is 20x squared. I like to combine these two before I distribute. How much is 2x minus 6x? Negative 4x multiplied by 5. Very good. Negative 20x. And how much is 5 times negative 3? Plus, and I copy the rest, 8x squared plus 8x plus 8, and close the bracket. All I have to do is now combine like terms inside. So 2x minus 3 to the 3rd, x squared plus x plus 1 to the 4th, they are just copied. And then 20x squared plus 8x squared is 28x squared. And negative 20x plus 8x is negative 12x. And this is minus 7. And this is it. A lot of work.
On the test, like, how many problems are we expecting to see, like, that length?
You mean like this?
Well, that length, like this, yeah.
Well, you will not have more than one problem, because then the test will be all about this, and there are so many different topics. No. It's just a lot of writing, but I don't think that, I think that what we did with the equations is way more difficult than this.
Mm-hmm.
The equations with even quadratic in form are more difficult, and the rational exponents more difficult than this. This is a lot of writing, though.
Yeah.
I agree. And if you miss something, the whole thing may collapse at the end. So I hope not. Other questions on this? Can you do the other 5 and check the answer? Okay. And if you don't get the answer on Tuesday, we can work on those. Okay. So we're ready now to, we have about 20 minutes. So let's start chapter 2. In chapter 2, we talk about graphs, functions, lines, etc., etc., etc. So our test 1 will be when we finish 2.1 through 2.5, not before. So any dates that are tentative, you can forget of those. So we will announce the test, we will review before the test, and we'll agree on the test when we finish these 5 sections. Not before. I'm sorry? Go ahead. I just didn't hear.
Is that the phrase you're talking about? Or
I'm talking about the first test of the semester. Will not be scheduled before we finish 2.1 through 2.5. Good. So in 2.1, we're going to look at functions and their characteristics and graphs and how we read this and how we read that. So what I'm hoping for Tuesday is that you do at least half of the problems from 1.1, 1.2, 1.5, 1.6, 1.7. Most probably we're not going to finish 2.1 in 20 minutes. So you're not yet responsible with this. But I'm hoping that you have at least half of each, and then you can go back and do more when you can. So try not to do the first half. Just do 2 problems and then skip 3, and then 2 more and then skip 3, and do 3 more and skip 2, whatever. So you're not only focusing on one topic, because many of those problems are probably similar. So it's a repetition thing. Okay. So you are always, moving forward with me, and you're not behind. Okay? Good. So let's look at 3 sets of bubbles. This is one set. This is the second set of pairs. So 3 pairs of bubbles. And here's the third one. Please choose 3 numbers for me that you want me to put in each first set. 2. -4 and 7. Perfect. 2, negative 4, and 7, 2 and negative 4 and 7 in the first set in all pairs of bubbles. Good. Give me 3 numbers in the second set of, let's say 0, doesn't matter really, 10, and 3. 0, 10, and 3. 0, 10, and 3. Now I'm going to connect numbers from the first bubble to numbers from the second bubble. I'm going to do this. So what I did here is just connected them the way I wanted them to be connected. The question now is, what is each and every representation? What does each and every pair represent? What is it? So first of all, the first set of bubbles is the set for x values. It's called domain. The second set is the set of y values, and it's called? Very good, awesome. X is also called input, and y is called? And this is valid for all 3 sets. A function represents or is a mechanism that makes each x value correspond to exactly one y value. So I'm trying to analyze this and see if it's a function. 2 corresponds to 0 only. Negative 4 corresponds to 3 only. And 7 corresponds to 10 only. So is this a function? Function. In the second situation, x corresponds only to 0. Negative 4 corresponds only to 0. 7 corresponds only to 3. Is this a function? Okay, one more time. Each x value has to correspond to only one y value. 2 corresponds to only one value, 0. Negative 4 corresponds to only one value, y value, 0. And 7 to only one y value, 3. Function or not? Very good. Let's analyze the last one. 2 corresponds to 0. Negative 4 corresponds to 0 and 10. 7 corresponds to 3. It's called a relation. It exists, it's possible, but it's not a function. Here's the next question I have. I would like you to understand that if it's a function or not, it doesn't matter. The first set is always domain, and the second set is always range. Can anyone identify the domain for us for all these 3? And it has to have, because we are listing the elements, we cannot use parentheses or brackets. We must use braces for both the range and the domain, because we are listing a finite number of numbers. Very good. Negative 4, comma 2, 7, and? Very good. Perfect. What if I now, so from the these representations, I was able to find which are functions and which are not. Now, what if I'm given some graphs? Let's say I have 3 graphs. Here's one. Here's another. And here's the third one. How do I identify which of the graphs represents a function and which one does not? Very good, very good. It's called a vertical line test. What does it do? If I draw a vertical line and it crosses the graph in only one point, I will only read one y value for this particular x value. If I draw another one anywhere I want in the domain, then I read only one y value. And I can do this forever for this one. Is it a function or not?
Yes.
Yes, this is a function. What about this one? Because if I show just one, it's sufficient to show one that for this x value, I will be reading two y values. This is not a function, it's a relation. What about the straight line or the linear function? Is it a function? Yes, I already said that. Good. Any questions on this? So these are all by the vertical line test. I would like to copy a graph. It will take me a second or two. Copy a graph from page 231, problem 82. So 1, 2, 3, 4. 1, 2, 1, 2. And here 1, 2, 3, 4. Okay. And this is 1, 2, 3, 4. Okay, here's the graph. We're given this graph and we're asked a lot of questions here. The first question is, does this represent the graph of a function? Yes, by the vertical line test, this is a function. Perfect. The next question is, let's identify the domain. Say it again. Very good. So the domain is always from the leftmost point. We are reading it on the x-axis. We are reading on the x-axis. From the leftmost point till the rightmost point. The leftmost point is here, and the rightmost point is here. So what will you read on the x-axis? Indeed, -6 to comma 0. Good. So now what do I put left and right? When I have infinitely many ordered pairs, I cannot use braces. Yes. What do I use here? But this is an open point. Very good. Parenthesis. And here? It's a full point, so it's a bracket. Any questions? Is this okay? Now I would like to identify the range. The range is determined from the lowest y value where the function exists till the largest y value. So this is 1, 2, 3, 4. I think it's, yes, I copied it correctly, correct. So this is, I'm sorry, this is -4 right here. This is -4. So from 2, okay, -3, comma 4. What do I write? Where? Perfect. Awesome. Okay, here's the next question. Find f of -2. Find f of -2. What is given in the question and what do I have to draw? What is it?
Evaluate the function of when x is equal to -2.
Very good. X equals -2 is a vertical line at -2. X equals -2. It crosses the graph in this point, and I need to read the y value. So according to my graph of -2 is -2. Can you tell me which ordered pair did you read from? Do you all agree that this is the x value and this is the y value?
Yeah.
Perfect. Now I'm going to ask one more question for this graph. Find, any questions? Please stop me if you have questions. I don't want to move on if you try to catch up. I don't like that. Is this okay? Do we understand what happens here? Yes? Okay. So now we want to find x such that f of x equals -1. Find x such that f of x equals -1. What is given now in the question? Yes, so it's given y equals -1. What type of line is that? Very good. So, very good, excellent. So when I graph the horizontal line, y equals -1, I see it crosses the graph in one point, and I need to read the corresponding x value. According to my graph, x equals -3. Which ordered pair did you read from? Very good, awesome. Do we understand this? Okay, two more questions here. Please find the x-intercept, if it exists, and then find the y-intercept. Yes, of course. So we want to find the x-intercept and the y-intercept. If they exist. So the x-intercept is where? Where the function does what? When it crosses the x-axis. Does this function cross the x-axis? Yes, right here at this point. Very good. So when x equals -4, please give me the ordered pair. Do you all agree with -4, 0? Okay, so let's come back and identify the y-intercept, if there is one.
0, -3.
Right, it's right here, it's 0, -3, awesome. 0, -3, or you can write y equals -3, but we prefer ordered pairs. Any questions on this? Yes, please.
So for the y-intercept?
Yes. Is where the graph of the function crosses or has a common point. It doesn't have to cross, but it has a common point at least with, yes, with the y-axis. So in this case, it's this point. It doesn't have to cross to the other side. It's still a y-intercept. Now, the x-intercepts are also called the zeros. Why? Because the function is 0. The zeros of f of x. One last thing before we adjourn tonight I would like to discuss is how to evaluate a function. So give me a function, any function you want. If you don't give me one, I will find one. Okay, so 2x minus 1 over x squared minus 3. This is a function. What type of function is it? Very good, awesome. It has x in the denominator and it has a fraction. It must be rational. Perfect. Let's say I would like you to look at this function and tell me what does it say to you. And then I'll tell you what it says to me. What does this function want you to do? What does it say to us? It says take the variable, multiply it by 2, subtract 1, then divide by the variable squared, subtract 3. When you're done, divide the top by the bottom. Do you all see this? Yes? So it says take the variable, multiply it by 2, subtract 1, then take the variable, square it, and subtract 3. When you're done with this and with this, divide the number from the top by the number from the bottom. Do we all see this?
Yes.
Perfect. Okay, so in other words, it really tells us this. So this is very clear, I think, that if I ask you, find f of 0, what will you do? Yes, plug 0 where you see the box, right? Because this is the variable, right? And you will say 2 times 0, and then you'll say 0 squared minus 3, correct? So this will be 0 minus 1 over 0 minus 3, so the answer will be 1/3. What if I ask you now to find f of, let's say, x plus h? What would you write? 2, but you will say parentheses, because otherwise it will multiply only x, not both. X plus h, and then minus 1 over,
X plus 3.
very good, minus 3. This is the procedure that we need to use for evaluating functions. And we are going to use this in the next section, and you will see what happens with that f of x plus h. So I did not finish to that one. I still have to show you, what I would like to show you is a little bit more, a couple of more graphs and discuss the domain and range. And then we can move on to 2.2. So assuming that I